All right. So let me close this.
I'm so sad the little box is gone. You haven't turned them in apparently before today.
You know what I haven't had in a
so
while?
many.
Pop rocks.
Are you selling them? Or no?
Oh, I bought that. Just take them out. That's what I'm doing. I
What?
have to buy something. No, you don't. Just get on the paper. Keep talking.
You sold us up, you're there too.
You
You know what I haven't had in a while? Pop rocks. Do you remember Pop Rocks? Pop Rocks? Yeah. When's the last time you had a Pop Rock? Exactly.
Probably last time.
All right.
You're weird. I've not had them either. Oh, when's the last time you had Pop Rocks?
Last time I had Pop Rock.
Exactly. See what I mean? Childhood thing. Goes away. I'm bringing it back.
Bag of Cheetos.
Okay. So
Did you know Ellen actually didn't come back to school?
in this chapter, we have
Shut up. So smart. Sorry.
a Ka and a Kb. If we have the item producing hydronium ions or H+ ions, then we need to use our Ka value. If we have it producing hydroxide ions, then we need to use a Kb value. We can then find something called pKa by taking the negative log of Ka. That's going to give us our pKa. And we can find the pKb by taking the negative log of Kb. And that'll give us the pKb. Both of these added together at 25 degrees Celsius will equal 14. Okay? Both of these multiplied, the Ka and Kb multiplied together at 25 degrees is equal to 1 times 10 to the negative 14.
The KB values or
The Ka and the Kb
1 times 10 to the negative 14?
Mhm.
Multiplied or added?
multiplied together. All right. We've talked about our 6 strong acids. Anything else is considered weak. So if we have a weak acid and it's in the presence of water, we have our back and forth arrow, meaning that we're going to be on both sides of it here. It's going to produce hydronium ions and it's going to produce a negative anion here. We can then use this value and plug it in and determine our Ka, or if we have Ka, we can determine our concentrations of these. Typically, this is given as a molarity. Okay? So this is what that equation looks like. And where are the majority of our materials going to be? Is it going to be on this side of the equation or this side of the equation?
On the reactants.
Reactants, because this is not a strong acid or a strong base, or strong acid in this case, which means most of the material is going to be on the reactant side. Okay?
Is there like a common ion effect for acids and bases? Is that
Well, let's not go there yet.
does that come up later?
We have something called buffers.
Same thing, same concept, kind of ish.
Ish.
I'll think an ish.
Ish.
She went.
It involves
Unless
stoichiometry
you said like flash.
and ice tables and molarity and probably a box or two of Kleenex.
There'll be melon stock though, because acid breakdowns going on. I might snap one of these days. You never know.
Weak bases then will react. They're going to pick up the hydrogen from over here, and that's going to leave an OH behind. And then if we take the concentration of that OH value, that's going to tell us our pOH. And with this guy, if we have OH over here, we're going to use KB. And that KB then is going to, we can work with that to figure out stuff, okay? So everybody cool with that? You can see with your KB would end up being the concentration of these over your base, okay? All right. Last thing that we're going to talk about today then is percent ionization. So when these break apart, so let's just talk about the acid one first, okay? And you can do the same thing with the base, but we're just going to use the acid for our example. When you have your HA plus your H2O, your double arrow, you have your H plus coming off and your A minus coming off, right? You can measure this H plus and the concentration of that and divide it by the concentration of your weak acid. And that will tell you then what percent of this guy turned into ions. Because remember, the majority of it's going to stay over here because it's a weak acid.
So you can do this just for weak acids, correct?
You can do it just for weak acids. You can do it just for weak bases too.
Because it's not where it's going to be 100%.
It would be 100% for the strong acids and bases. So that's why we don't bother to do that for them. Because the percent ionization for them would be 100%. Or thereabouts.
Yeah.
Because most of them end up on this side for strong acids and
I'm
bases.
assuming there's more than just those 6, but we just cover those.
Yeah. Those are kind of the generally accepted ones. There's a few other ones out there, but
They're not necessary.
yeah, and like even in college, they just have you pretty much memorize the 6. I'm sure if you get into like the advanced chem, they may get into more, but the majority of them don't. I mean, most of them stay on this side.
Is there a
So
reason that those 6 are special?
I believe it has to do with higher electronegativities.
So the ability for them to give and take.
Yeah. All right, so we know the Ka for this is 7.54. They want to know what the pH of this solution is going to be. All right, so we have, this is our weak acid, so HClO. We're going to put that into some water. It's going to disassociate with my sad little arrow there that isn't looking too healthy. My apologies. Plus ClO minus. Okay. So ice table. Here we go. Initially, I have the molarity for my weak acid is 0.1. Not going to worry about my water. I don't have any of these guys initially, but over time, I'm going to lose some of this. And I'm going to gain over here. Everybody cool with my math so far? All right. So now I know that my Ka is going to equal my H plus, my ClO minus, and that's going to be over the concentration of HA. So we need to start plugging some numbers in here, or values, okay? I don't know yet if I can ignore this X. I've got to figure out what my Ka value is.
When would be over HClO?
They didn't tell me what my Ka value is, but they told me what my pKa value is. So I can take 10 to the negative 7.54 0.4, and that's going to give me my Ka value. That makes sense? With your knowledge of logarithms.
Do we already work at base 10 for logs here?
Yeah. Thank the dear Lord above. All right.
I don't think I can deal with the change of base formulas.
So my Ka then is going to equal 2.9 times 10 to the minus 8. Does this number make sense?
Yes.
Okay. So always go back and kind of double check to see if that makes kind of a logical linear sense. If you got 10 to the negative 3, something's wrong. Okay. All right. So I know this value. I can plug that into my equation now. I also know this is 10 to the negative 8. I also know then that I can ignore this x. Ignore. Yeah, so if you take this, if you take 0.1 over 2.9 times 10 to the minus 8, it ends up being like 3 million something, okay? If it's greater than 100, you can ignore that, okay? And I think it was Jaden today brought up a good point. If this is 2 orders of magnitude different than this, then you could ignore it. This would be -1, so negative, more than -3. Then you can ignore it. And know that for AP, they're not going to make you use the quadratic. So it's pretty safe bet that you're going to be able to ignore that. Okay? All right. So we've got that equal. That's going to be equal to x times x. This is x, which is x squared, over 0.1. So I'm going to multiply by 0.1, which will be 2.9 times 10 to the negative 9. I'm going to take the square root of that, and that's going to give me x. So x then will equal 5.4 times 10 to the negative 5. Okay, so they didn't want to know, this equals my H plus concentration. That's not what they wanted to know though, was it? What do they want? pH. So I need to take the negative log of this value, and that's going to give me my pH. What should my pH be around? It should be around +5, somewhere around 5, right? And it ends up being 4.27. Okay. So just as a quick little check, go back and make sure that you didn't fat finger something. Okay. I mean, it's not going to tell you definitively where you got that, if you got the answer right or not, but it's at least going to get you in the ballpark, right? All right. Questions on that guy?
So when should it ignore the x?
When?
Yeah, when should it ignore the x?
So if you take your initial amount here and divide it by your Ka value, or your K value for whichever, wherever you're working in, if that is greater, so this ends up being 3 million-ish, like it's in that range, okay? If that value is greater than 100, okay, then you can ignore this x. And if you think about it, Gigi, if we went back here and did 0.1 minus this amount, it's going to be so tiny that it's still going to be 0.1 because of sig figs. So this isn't going to make a difference in this amount. This amount is so many magnitudes larger than this that it's not going to make a dent in that. Does that make sense?
Yeah.
Why did you know, I mean, the pH would be around 5
Because if this is your H concentration, if you look at this right here, your pH is going to, if you take that negative away, it's going to be close to that value. So whatever 10 to the whatever is going to be close to that pH value then. That's just the way logs work. If you want more than that, you're going to have to probably go talk to a math teacher. All right.
Are we skipping over these middle?
No, we're not. That's where they got me, and then they got me off track, and no. It was ugly. Okay, let me get over to that. It was ugly.
Did you get mad?
No, I didn't get mad. I got mad at myself. I was very frustrated with myself because I didn't feel like I was as prepared as I should have been for their class. So, all right, let me get down. This is on page 16 on here.
Okay, so I did it wrong. I did it right. I did it wrong.
All right, I believe this is where you start, right?
Yes.
Okay. All right, so when we're calculating these, this is giving us methylamine, okay? So this is of a weak base. So this is going to be our base plus water is going to give us HB plus OH minus. Okay? Because what's going to happen is this base is going to grab one of these H's from here and form this. And it's also, when it takes that H away from here, it's going to leave an OH behind.
Wait, so ice tables.
Okay? All right. So they're telling me that my pH of my base here is 0.1. I'm going to lose X, and I'm going to have 0.1 minus X here. This I don't care about.
No, it says the pH is 1. Okay.
Oh, I did that. Okay, yeah, you're right. Sorry. There. Better? Okay. I did that when I was trying to do these earlier today, and yeah,
Yeah, no,
I just can't. I can't be learned today.
No, I get it. It's okay.
All right, so this is +1, this is +1, or X, I mean, and this will be X and X. All right, now, is this 2 orders of magnitude different than this?
Yes.
Yes, so we can ignore this. Or if you want to do 1 divided by this guy, it's going to end up being a number greater than 100. Okay, however you want to think about it. All right. So this is going to give us our KB. So our KB is 4.38 times 10 to the minus 4. That is going to equal our HB, OH minus over our base. Sub in those values then. That's going to equal X squared over 1. Hi.
Did turn in my Valentine's Day cards.
Oh, okay. Underneath the there's a basket right there that says turn in basket. There's a basket underneath. There you go. Do you have your name on them?
Yeah.
Okay, thank you. All right. So this then, when we solve for X, what do we get? calculator. Where would I be?
I can't do it.
4.38 to the minus 4. I'm going to take the square root of that. Okay. So x is going to equal 0.0209, and that's molar OH minus, because remember, that's what x is, right? So if I do the negative log of 0.0209, that is going to equal what?
And then that's gonna equal your POH.
POH,
You're
right.
gonna subtract that from 14 to get your POH. Right?
So that's going to, my pH, which equals my POH, my bad, is going to equal 1.7, no, 6. God damn it. Sorry, y'all.
No, you're good.
1 point, I can, honestly, I can round. There we go, 1.68. That's my POH.
You subtract that from
So now if I subtract that from 14, it's going to give me my pH.
So why can you do this here? Like you can only do it when it's in water. However, you assuming that it's your water 25 degrees.
We're assuming that it's, yeah, yep. And it's not pure
Or
water,
just water.
but it's a solution. This would be a basic solution at 25 degrees.
Unless it says otherwise, that's what
Mhm.
it is.
And most of the time, and remember that 25 degrees is 298 Kelvin. They're the same thing,
You add.
273. Okay? So does that make sense? All right. So when we have salts that go into our water, we can have things called neutral salts. A neutral salt, the cation would make a strong base. So NaOH, for example, is a strong base. And the anion of that would make a strong acid. So that when these go into the water, they're not going to be changing or modifying what's happening with the water.
That's like that's why it's a P.
Mm-hmm. Okay. Now, this is where you're going to have to wrap your brain a little bit. Okay. This is called a basic salt because when you take this guy, he breaks apart. He's going to have K, which would be KOH, right? That is a strong base, so those are going to stay apart. They're not going to come together because that would be a strong base. Remember, a strong base, these two things are not going to want to be together. Okay? But this guy here is going to want to go together with an H plus, okay, from water. He is going to form, so your water here, actually I should do this as H2O. Let me do this as H2O. Okay. He's going to grab a hold of an H. He's going to form acetic acid then. And a hydroxide ion. So if he forms a hydroxide ion, we can measure the concentration of that hydroxide ion. He's going to make that water more basic.
Makes sense.
Because he's going to increase the hydroxide ion concentration in that water.
So basically, if you have salt that dissolves in water, you mix a strong acid and a strong base, it's neutral. You mix just a strong base, it's basic salt. You mix just a strong acid, it's an acidic salt.
Mm-hmm. So down here, you can also have acidic salts. So for acidic salts, when that happens, they're going to glob on and they're going to be adding in more. They're going to grab and they're going to donate one of these H's over to the water. And remember, this is H plus. That is what we measure. The hydrogen ion concentration is how we measure if something's acidic or not. So strong acid, this is your weak base.
That was just an arguing walk. Mom told me who her boyfriend is. I'm going to yell at you.
I don't know. That would be a historical thing. You'd have to go back and kind of. All right, so let's look at this guy. If we have sodium here, our sodium would form a strong acid. So he's not going to have any effect on the pH. But this guy, the acetate, okay, he is going to, when he gets into water, he's going to split the water here. He's going to end up grabbing a hold of the H from here. And he's going to increase the hydroxide concentration then. No. So this is a basic salt. This is a basic salt here. Here, this guy right here, HNO3 is a strong acid. So you're going to have your NH4 plus H2O. He is going to donate a hydrogen over to the water and have NH3 left over. So here, we're going to increase the H plus concentration, which makes this an acidic salt. I told you you'd have to wrap your brain around these a little bit. You were warned. Okay, so which one is this going to be? This guy right here would be a strong acid. Okay, so that means that our aluminum then is going to come in. He's going to be a 3 plus here. He's going to take our water then. He is going to grab a hold of and then that's going to give off H plus, so that would make this acidic. He's a cation. So he's going to pull in the OH here, which is an anion, and leave this behind. That's going to increase your H plus concentration, which makes that acidic.
So basically, unless there are two things combined together that will come out to be one in a strong acid and one in a strong base, it'll always be the basic result. So it'll most of the time seem to be one.
Yeah. And if it's your cation, that is going to be the one that is left behind, that's not the strong one, okay? Then it's going to be acidic because that's going to grab a hold of the OH, okay? If it ends up being the anion, then it's going to be a basic salt.
Where did they go?
I don't know.
They left.
I don't have time to deal with. Okay, so This guy right here, NaOH, right, is a strong acid. So that means that my F is going to be what we're going to focus on. Okay? So if I have F and he is put into water, what is he going to grab a hold of?
He's gonna have a hold of the H plus.
He's going to form HF. And what's he going to leave behind then? OH minus. Now, if I have OH over here, okay, I can't use Ka because OH doesn't relate to A, it relates to B. So in order to do this thing, I've got to calculate my Kb. And Kb at 25 degrees Celsius, which we're going to assume we're at because they didn't say any different, Kb is 1 times 10 to the negative 14 divided by 7.2 times 10 to the minus 4. That's going to give me my Kb value. Huh? Oh, you ain't seen nothing yet, honey. This is as bad as it's going to get today, though. All right. I got 1.39 times 10 to the minus 11. Right? This guy is going to be 0.3 minus x. We're going to ignore our x. And we're going to have x and x here. Okay? So 1.39 times 10 to the minus 11 equals x squared over 0.3. Take the square root of that. And I've got my OH concentration equaling 2.04 times 10 to the minus 6. So, what do I do from here? This should be easy. Yep. Do what?
Would you divide that by 1.0? Oh, no, you.
Well, I could if I wanted to find my height. But what's the faster way to do this? Negative log. Okay. So if I take the negative log of 2.04 times 10 to the negative 6, that's going to give me my POH. So negative log, that's going to be a lot faster to go than the other way. So this is 5.69. And if I subtract that from 14, that is my answer.
Gosh. A lot of money. You were great. Yeah.
All right. This guy right here, strong acid. So that means this guy is the one that we're going to want to concentrate on. So NH4
Nicole, come in.
plus,
Hi.
hi,
I put in my cards.
Over there.
see the turn-in basket?
One underneath it.
The one underneath it. You'll see some cards in there already.
Yep.
Yeah, is your name on them?
Yeah.
Okay, thank you. Have a good day.
Okay.
Hi, Nicole.
Plus H2O is going to give me NH3 plus H plus. Okay. Ignore this. This is 0.1, so it's going to be 0.1 minus X, X, X. Everybody okay with my abbreviated ice table?
Yes.
All right. Again, I've got an H ion here, so Kb will not serve me well. What do I need to do?
1 times 10 to the negative 14.
Okay, I need to find Ka. 1 times 10 to the minus 14 divided by 1.8 times 10 to the minus 5. That will give me my Ka value. Negative 14, 8, negative 5. And I end up with 5.56 times 10 to the minus 10. All right. I can ignore this puppy, because that is a lot of orders of magnitude different between that guy. Yes? Okay. So that means that 5.56 times 10 to the minus 10 equals x squared over 0.1. 5.56 times 10 to the minus 10 times 0.1. And then I am going to do what with that? Take the square root of it. So that tells me that my H plus concentration equals 7.45 times 10 to the minus 6. How do I find my pH? I'm going to take the negative log of this value, and here's my answer. We'll do 23 as a warm-up on Monday. You have the rest of 8-3 to finish this weekend, okay? And I can't, for some reason, find it. It's not coming up on here. I don't know what's going on with this, why I can't. It's like stuff's disappearing on here. Here we go. So the rest of 8-3 is homework tonight. And you can go, if you have a QR reader, you can go and click on this and it'll bring up a video for you. And you can watch the video on how to do this if you're lost. Yes.
So the opening statement is here. If you can notice, I think the revised and
I